Hello, welcome again to a second example by this proof by induction. Example 2, we want to prove by means of mathematical induction that Zume of I beginning from 1 to n is equal to n bracket n plus 1 all over 2. So we're asked to prove that this formula is true. So solution now. As usual, we begin again with our base case. In our base case, we assume that 1 is equal to 1. Okay, so anywhere we see 1, anywhere you see n in this formula, we replace it by 1. So let's go. We have Zume of I, and I is beginning from 1 to 1, equal to 1 bracket 1 plus 1 all over 2. So here now we have replaced all the n with 1, so that Zume of I from I equal to 1 to 1 will just give you 1. Okay, and from here now we have 1 plus 1 is 2 all over 2. You're going to have what? 1. So we see that the left hand side is equal to the right hand side. So therefore the formula holds what? True. The base case holds true. Now we project further to induction hypothesis. Induction hypothesis IH. So here now we want to assume, in our induction hypothesis, we assume that for some integer k, which is also an element of a natural number, without 0, that this formula above is also applicable, or the formula holds, is also applicable. So that we now have the Zume of I from I equal to 1 to k will now give us k plus 1 all over 2. Okay, so in our induction step now, so we want to show that the formula is true, is also true when k is projected to k plus 1. That is what we want to show. Okay, so remember that our Zume of I, when I begins from 1 to k, is k plus 1 all over 2. So now when k is k plus 1, anywhere you see k, you replace it with k plus 1. So we have k plus 1. Zume of I beginning from 1 to k plus 1 is equal to k plus 1. So we are replacing this k now with k plus 1. Then we'll have to replace this k again with another k plus 1, plus another plus 1 all over 2. Yeah. Okay. So having done that, we can now simplify. Yes, we can simplify further. We have Zume k plus 1. Write this one. Zume k plus 1. Zume of I beginning from 1 to k plus 1 is equal to k plus 1, k plus 2 all over 2. Okay. Now from the left hand side, we know that Zume of I beginning from 1 to k plus 1 can be written as in it can be broken down to Zume of I beginning from 1 to k plus k plus 1. It can be broken down. So what we now have to do is to substitute this substitute this. Okay, let's write it down. We have to substitute the induction hypothesis, which is equal to k resume of I beginning from 1 to k, which is given as k plus 1 over 2. We have to substitute it into the equation. Okay, so that this is how it will look like. We have k plus 1. We have resume of I beginning from 1 to k plus 1 will now be k. We have to substitute this. Substitute this to this. So we have k plus 1 all over 2 plus now this k plus 1. Okay, so further simplification will give us, but we know that k plus 1 can also be written as 2k plus 1 all over 2. We just rewrote this k plus 1 so that it will have the same base with this. Okay, it will have the same base. So we rewrote this k plus 1 so that it will have the same base with this. So we now have resume of I is equal to 1, k plus 1 will now give us k plus 1 all over 2 plus 2k plus 1 all over 2. So it is now easier for us to calculate. So we have resume of I beginning from 1 to k plus 1 will now, since they have the same base, further simplification will have k plus 2 factorization is actually what is called in mathematics, k plus 2 k plus 1. So since they have the same k plus 1 here, we'll pick one and then combine these two. Okay, and then they have the same base of 2. So we have proven that this formula holds true. So you say, since we can prove that resume of I beginning from 1 to k plus 1 is equal to k plus 1 k plus 2 all over 2. Therefore, it means that this formula, the initial formula that was given to us, which is resume of I beginning from 1 to n is equal to n plus 1 all over 2, that this formula is true. Okay, thanks for watching. Drop your likes and comments in the comment section. Thank you. Till next time. Bye.